realized what happened. I gave you some problems that I didn't mean to give you on the review, so I'm sorry about that. I will tell you in class. But we're going to pick up on 44. This is the next part that I care about for you. What is the vertex of a quadratic? Not to teach this all to you again, but the vertex is the highest or lowest point. So if it opens downward, there's our vertex. Opens upward, there's our vertex. What is a parabola? That's the shape of a quadratic. Okay, symmetric on both sides. What is an axis of symmetry? That's this vertical line that goes through there. We have an equation for it of opposite of b over 2a, which apparently I'm asking down there. There's just a lot we need to know about quadratics. What is vertex form? Vertex form is if we go a times x minus h quantity squared plus k. Okay, we'll go there. What is standard form? Well, that would be if we were in y equals ax squared plus bx plus c. And this is stuff we've done relatively recently. So hopefully it'll come back to you and make sense as we go through this. Okay? Alright, so looking on our next problem, 45 here. Let me move it down. This is in vertex form. It's perfectly in vertex form. So we don't need to do any work. Just look at it and be like, okay, the vertex is 1. It's opposite of what we see here, comma, 10, but negative, okay, because it's the same as what we see there. And the reason is, again, I'm going to write this right next to here, a times x minus h. So that means our h value is 1. It just sits in there perfect, but the formula does say plus k, so that means it's a negative 10 on the back end. So if I'm going to go graph this, I'll try my best here. I'm going to go right 1 and then down 10. So there is the vertex right there. Now, the way we're going to get the rest of the points are to build off of this a value. If the a value is 1, we'd go over 1 up 1, but it's not. It's 4. So I have to go up 4 times what I normally would. So watch this. Over 1 up 1, 2, 3, 4. So I'm right there. Sorry. Sometimes that happens. Over 1 up 1, 2, 3, 1, 2, 3, 4. Right there. Now, that's going to be symmetric on this side, so there will be a point right there. And then normally I go over 2 up 4, because 2 squared is 4. I normally go up 4, but now I got to go up 4 times 4, which would be 16. So here's up 10, and then 11, 12, 13, 14, 15. It would be way up here. And then I'm going to go over 1, 2, 1, 2 to make this symmetrical. And then this is going to be really scary, but I'm going to try to sketch this on here. It's not the easiest to do. Whoa, don't laugh at me. There we go. Got it. Whoa, come. I can't even make you think that that possibly is okay. So I'm going to try it again. Alright, so we're going to come down through here, touch the vertex, and come back up. I apologize. We've done quadratics. You know they're not supposed to look with like a dent in there, so I apologize. But that's the idea there. Okay, that's how we graph those. The axis of symmetry, I wanted to talk about that at the end. That's going to be for this problem, x equals 1. It's wherever the x value of the vertex is. So it's literally the vertical line, and hopefully you can see the graph is symmetric about that line. Mine is not, because mine got like kneed in the side or something like that. But I will try better on this next one. Alright, so the vertex for this one is going to be negative 5. Okay, again, opposite of what we see on the inside, and then comma negative 2. So that would be, let's see this, 1, 2, 3, 4, 5, 1, 2, right there. It's going to open which way? Upward again, because it's positive. The axis of symmetry is x equals negative 5. Let me try to make that with red here. Let's see if I can be successful bringing that up. So that's the axis of symmetry. But here's the deal. It's going to be a little different now. We have a 1/4 out there. Instead of going up 4 times as much, it's 1/4 as much. So here's the easiest way to do it. We know that we go over 2 up 4, right? 1, 2, 3, 4. So we're going to go up 1/4 of what we normally do. Well, 1/4 of 4 is 1. So there's going to be over 2 up just 1 this time. When we normally go up 4, so 4 is normal, we're going to go up 1/4 of that, which would be 1. Now here's another one. If I go over 4, 1, 2, 3, 4, a normal graph is up 16 because 4 squared is 16. But now I'm only going to go up 1/4 of that, which is 4. So 1, 2, 3, 4, up 1, 2, 3, 4 there, and then keep it symmetric here. So actually, and this isn't going to be a perfect sketch either. Ooh, it's better, it's better, it's better. Oh man, that's pretty good. All right, it's going to be a little bit wider here. Okay, wider made it easier for me to sketch. Okay, so what are we doing on the next one? Now, different procedure. You have to first find the axis of symmetry. So x equals negative b over 2a. So here we go. So x is equivalent to the opposite of b, so the opposite of negative 32, all over 2 times a, which is 2. All right, so what do we got here? We got 32 over 4. So our axis of symmetry is 8. So that's the first thing we find using this procedure. Just look at the directions on your final and understand which procedure you're doing. All right, so 10, 9, 8. So this is going to be my axis of symmetry here. Right there. Well, here's the deal. I know the vertex is on there, so here's the kicker. I know that 8 is the x value of the vertex. I just got to go find it. Well, that's where we plug it in. So my y value is equal to 2 times 8 squared minus 32 times 8, and then plus 129. So what do we got here? Order of operations, we got 8 squared, 64 times 2, so we have 128. Minus, what do we got here? We got 32 times 8, so that's 256. And then we're going to add 129. Well, look at this. We got our y value coming out to 128 minus 256 is actually negative 128, plus 129 is a positive 1. So our vertex is going to be 8, 1. So again, I'm going to go over 8, and I'm going to go up 1. That's my vertex. Does this open upwards or downwards? Looks like it opens upwards. And we do have to worry about the stretch. We have an a value of 2. So instead of normally over 1 up 1, I'm going up 2. Normally I go over 2 up 4, but I'm going to go up 1, 2, 3, 4. I lost track. 1, 2, 3, 4, 5, 6, 7. We're going to go up 8 because of the stretch factor, because of the a value being 2. All right, and then we're going to sketch our parabola. Wow, I'm getting better at this as it goes along. Okay, so hopefully that helps. You find the axis of symmetry, you plug in that, and then you get your y value of your vertex, and it's all there. All right, let's try it here. Again, x equals opposite of b. So the opposite of negative 18 is positive 18, all over 2 times a. So that's going to be a negative 6. So we're getting an axis of symmetry of x equal to negative 3. It's an equation, remember. So x equals negative 3 is what we want to write. Okay, so then if we go over here, 1, 2, 3, there is the vertical line here that we're going to be symmetric about. So that means we have a negative 3 for our x value. What's the y value? We have to plug it in. So y is equivalent to negative 3 times negative 3 squared minus 18. Uh-oh. We got to really be careful of all these negatives. Let's take it slow. So the opposite of 3 squared is the first thing we have to do. That becomes a positive 9. But then we multiply by the negative 3. So that's a negative 27 coming out of right here. Then we have a negative times a negative. That's a positive. And that number comes out to 54. And then minus 32 on the back end. Now go left to right. You actually get negative 27 plus 24. You get a positive 27. Minus 32 comes out to a negative 5. So just order of operations, make sure you're spot on there. And then we're going to go negative 3, 1, 2, 3, 4, 5, negative 5. And this one actually opens down, okay, because we have a negative, and it's got a stretch factor of 3. I put a lot of these on the review just so we can practice them. Again, normally it's just over 1, down 1, but this is over 1, down 1, 2, 3. And this one's over 1, down 1, 2, 3. Okay, so that's actually all we're going to be able to graph as far as points go on this one. Okay, now we're moving on to the completing the square method for the quadratics here. And this is the one with the blanks. Okay, so remember, complete the square means blanks. Alright, so what I did here, and you guys actually liked this one a lot, is I had x squared plus 8x and then we had plus something. And then we put the plus 10 over here, and then we said minus something. We are all on one side of the equal sign, so instead of adding to both sides, we're going to add to one side and subtract the same thing to one side. Well, here we go. Try to remember what it is. You remember? Half of 8, 4. 4 squared, 16. Half of this number squared goes in here, and it goes right there. So this becomes y equals, and then in parentheses, I'm going a little fast here, sorry. But this right here is what we now want to factor. And if you actually went and factored that, just show you this here, if we went and factored that, that would actually be x plus, and it's going to end up being 4 and 4. That's what works here. Well, anything times itself is that squared. So that's the beauty of this, is you have just perfected this square, and then in the back end you have a minus 6 because plus 10 minus 16 is here. So we basically put it into vertex form. That's our goal. And then we can just say, oh, the vertex is negative 4, negative 6. Axis of symmetry, x equals negative 4. And if you don't get that real well, I've been talking about that for the last few problems, so maybe go back and watch the video on those. All right, but what we want to do then is graph, and we've got all the goods. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. There's negative 4, negative 6. And then axis of symmetry is not perfect by me. Wow, sorry, but the pen's messing up on me now. But right there. And then we just have an a value of 1, so we can go over 1, up 1. This is a good normal graph. Over 2, up 1, 2, 3, 4. Normally we go over 3, and we go up 1, 2, 3, 4, 5, 6, 7, 8, 9. That's as far as I'm going to go, but I'll make it symmetric on both sides here. Okay, so then we would just sketch our graph. I would do more, but this is frustrating using this pen. It's not perfect. Okay, so it's going to look like that. Alright, let's see what else we got here before we move on. One more of these, and then I'll probably stop the video. I don't like to make the videos very long, and then I'll pick up on quadratic formula. So again, the blanks, y equals x squared minus 18x plus blank plus 84. And then we have minus blank, half of 18, 9, 9 squared. Don't mind if I do, 81. And then what do we have here? Y equals x minus 9 quantity squared plus 3. You always, when you factor this, you take half of whatever that is right there. You use the exact same sign, and that's going to give you your perfect square there. And then plus 3 on the back end. So our vertex, lots of practice with this, is going to be 9, 3, 9, 3. The axis of symmetry is x equals 9. So over here, there's our axis of symmetry here. And then the vertex is over 1, 2, up 3. And then it's just open upwards normal. We could go over more on this too. 1, 2, 3, 4. Just because it's the edge of the graph, don't stop your graph here. It does continue on through. Alright, I'm going to stop this video, and then we'll finish strong.